These two rockets are fully 3D printed, and the only difference is this one here is mostly made out of PLA Plus, and this one here is fully printed with a resin printer, so all the parts are using a resin instead of a filament. And these rockets are going to be able to surpass Mach 2 using a 54 millimeter motor, either like a K-size motor or an L-size motor. And all of these rockets, as usual, there's no paint, no sanding, no drilling, and so they're very easy to print, and they go directly from printer to the launch pad. So this one here, the resin printer, it's using two types of resin. This section here, the tail section in this part of the body, are designed with a high deflection temperature resin, so it'll withstand the frictional heat from flying over Mach 2. The fins are extremely profiled, using filleting, knife edges, and rounding to make this. It's super smooth right off the printer. That's the beauty of the resin printer, is it makes parts that are super accurate, super smooth. So I'll tear this down to show you what's inside. So let's start off with the payload section. So this is the payload section that contains the parachute, the recovery system, and it unscrews right here in order to have access to the nose cone and all of the E-bay. This is one of my screw-in E-bays that screws in and out. And you've seen these before if you've looked at my other videos. This one here is designed with a GPS telemetry transmitter and an altimeter that goes here, and the LiPo battery is located here. So it's all one unit. It screws in here, and then out of this here would normally be a canister for the black powder, and it would be situated right here. And of course, there's an eye bolt for the recovery system. So this nose cone also unscrews, and so you can see this is made from this part here, which is sort of the key to it all. It's one part that has 3 sets of threads. Threads here, threads on the inside for the nose cone, and threads in here for the E-bay. So the equivalent part on this rocket is seen here. All these parts are interchangeable. In other words, I can take PLA parts and mix them with resin parts, or vice versa. As an example, this one here is PLA with a resin, this fluorescent neon pink. These two parts are made out of resin, but I also have the equivalent in, for example, this nose cone here. This nose cone here is PLA down here, and then the nose tip is made out of a high temperature resin. So here's another example of the payload section. So that would be the equivalent of this part here. Again, with the part here. Now this is made out of, all this is 3D printed in resin. This is a clear resin, and then this here is a resin that starts off as white, but I can add dye to get the color I want. That's one of the advantages of resin printing, is you can dye the resin to anything you want. You can also mix resins to get the compromise that you want between high temperature, deflection, and flexibility. These rockets are not at all brittle. The resin I use is actually it's called an ABS-like resin, and so it's actually very flexible. I can take this thing and just beat it. I don't want to beat it on this antique table, but I can beat it on the table. I mean, it's not going to break. I can't break this by just beating it on something that's so strong. So the tail section, in the case of the resin rocket, is made out of 3 parts. In the 3D printer, it's only the filament printer is only made out of 2 parts. That's because I have 400 millimeters on my filament printer. I only have 260 millimeters height in Z for my resin printer. So this has a draw rod a 1/4-20 draw rod here. And so the motor, in this case, this is a K-size motor that screws in and screws in and out. And it's attached to the draw rod here. And so once that's unscrewed, it comes out. And so this is would be a K-size motor. Is a 4-grain, 54 millimeter minimum diameter. And then I'll probably, to really bust Mach 2, probably need to go to like an L-size motor, so like an L1000 motor. And this is designed to accommodate the L1000 motor because it's longer. It'll be up to here. So I'll launch it first with this little K motor, and then at some other time launch it with the L motor if everything works. So here's some other parts. This here is another tail section. This is resin printed in the same neon pink. This is all resin printed, very extremely precise. You can see the fins are just extremely smooth. Everything's really smooth. That's again the beauty of the resin printer. It's super accurate, and it's really smooth, and it's stronger. It's stronger than any of the filament printer plastics, and it's also higher heat deflection temperature. It is a little bit messy to print, and it takes a place that has a good aeration and everything too, because of all the fumes, not only for the resin you're using, but also you have to wash everything in isopropyl alcohol, and that stinks like crazy. So there you go. That's my opinion on resin printing, is that these rockets will be more and more resin printed because there's so many advantages to it. There's some disadvantages, but like I said, from the material sciences point of view, you can have these very strong and heat-resistant resins. The printing is just absolutely drop-dead gorgeous. It's super smooth. There's no finishing that's required. There's no paint required. And of course, you don't have to sand or drill anything. You can print all your holes. In this example here, the body tube that goes here, it has all of the shear pin holes that are printed and ready to, and they're all perfectly aligned. You have your holes for pressurization or depressurization to allow the pressure inside the payload section to be at the ambient outside pressure. So there you go.